Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Border Gateway Protocol. Specifically within BGP, we're going to be taking a look at external BGP and how to set it up between three different routers, specifically Juniper routers. So in this network diagram we have again three routers, router 1, router 2, and router 3. Router 1 is in Autonomous System 100. Router 2 is in Autonomous System 200, and Router 3 is in Autonomous System 300. So what we're going to do in this lab is we're going to set up using logical tunnels and logical systems on one physical Juniper router. We're going to set up external BGP between these three routers. We're going to connect them together using their logical tunnel interfaces. For instance, the connection between router 1 and router 2, router 1 is going to be using logical tunnel 120.12. Router 2 is going to be using logical tunnel 120.21. And then the connection between router 2 and router 3, router 2 is going to use logical tunnel 23, and router 3 is going to be using logical tunnel 32. The network between router 1 and router 2 is the 12 network, and the network between router 2 and router 3 is the 23 network. Router 3 has a loopback 0.3 interface, and under that interface it has two different subnets, the 3 subnet and the 33 subnet. And router 1 has a loopback 0.1 with the two subnets, the 1 subnet and the 11 subnet. And what we're going to do on router 1 and router 3 is we're going to advertise these loopbacks. We're going to advertise these networks within, or these loopbacks into BGP. And then we're just going to take a look at some of the basics of external BGP. External BGP is a BGP connection between two different autonomous systems. So that's the main difference between internal and external BGP, is that internal BGP is a BGP connection between two different routers within the same autonomous system. And BGP is the protocol that is run across all the service providers and makes up what we call today the Internet. So without BGP we would really have no internets, because BGP is a combination, and the Internet is a combination of all the different autonomous systems connected together. And the reason that BGP is used is because it is very robust, scalable, and you can control and manipulate routing in a lot of different ways. You can use what's known as BGP attributes, such as multi-exit discriminator and autonomous system path. There's a lot of BGP attributes, origin, and so on that you can use and tweak to control how your routes are seen by other autonomous systems and within your own autonomous system if you have an internal BGP connection between two routers. BGP also uses TCP port 79 for transport. So let's go ahead and get right into configuring and setting up our lab. Again, in this lab we're going to set up everything from the interfaces to external BGP. So the first thing I'm going to do is go into configuration mode, and we're going to create our logical systems first. So set logical systems R1, and then again our interfaces that we're going to use are the LT interfaces. Again, if we take a look at our diagram, if you have three physical Juniper routers, this lab you can do, I'm just doing this on one physical Juniper router and separating them with logical systems. If you're not familiar with logical systems, you can watch my logical systems video Logical Systems Lab 1, where I show you how to use logical tunnels. Again, this lab you can do if you have 3 routers physically connected together. Just replace your logical tunnel interface with whatever your physical interface is between your routers. So let's go ahead and create these logical tunnels. 120 dot, again, for R1 we're going to be using unit 12. I'm going to create our IP address. It's going to be 12.12.12.1/24. Oops, forgot the address. So I'm going to set these up rather quickly, so if you're wondering what these commands are again, what I would do is go and watch my Logical Systems Lab 1, and that is where I explain exactly what I'm doing right now. So I'm just going to run through this pretty quick. That way we can get on to our external BGP demonstration. Right now what I'm doing is I'm on R2 already, just configuring the peer unit to 12, which is our connection to router 1, and last the encapsulation type, which is Ethernet. And now on router 2 I'm going to set up my connection to router 3. So the first time you do logical systems, it can be kind of tricky to figure out all the commands, but once you do it a couple times, you'll find out that you can pretty much fly through setting up connections between routers, and that's the power of logical systems. You can create a network topology very quickly. Again, our peer unit from router 3 to router 2 is going to be 23, and the encapsulation type is going to be Ethernet. Last thing, what I forgot to do on R1, what I'm going to do on R3 is forgot to create our loopback. So we're going to create on R3, if we go to our network diagram, we are creating loopback 0 unit 3. So again, when we're doing logical systems, you cannot have, so these two routers cannot have the same unit, logical unit. So R1 can't have unit 1 and R3 can't have unit 1 as well. However, if you're doing this with 3 actual physical routers, then you can do that, that's fine. Just wanted to let you know for the purpose of the lab why we're doing this. So again, we're going to have the subnets, the 3 network and the 33 network. Then also we'll go under R1, interface loopback 0, unit 1, family inet with the address of 1.1.1.1/24. Then also the 11 network. And that's it. So that should be it. That should be our basic configuration. Wasn't too bad, right? We got it all configured fairly quickly. Now what I'm going to do is I'm just going to log into R2 and just verify. We can do that by the command set CLI logical system R2. Now that it looks like I'm at the command prompt of R2, if I just do a show route, see that I have connections to router 1 and router 3. Let's go ahead and ping these. So 12.12.12.1, that's my connection from R2 to R1. You can see that we are successful. And then the last connection would be, from R2's point of view, would be to router 3. So 23.23.23.3, which would be R3, and you can see that we have reachability. So the basics, we just configured all the interfaces, And now we're going to go ahead and jump into our BGP configuration. The first thing we're going to do is we're going to go ahead and set up R1 first. So let's go to R1. And we're going to do the command set CLI logical system R1. So this brings us to the command prompt of R1. We're going to get into configuration mode, and the first thing we're going to do is the command set routing options. And if I do a question mark, you can see that we have an option for autonomous system. So this is where we're going to specify on R1 our autonomous system to use. So set routing options, autonomous system, and then you can see we have the option for the AS number. Router 1 is using autonomous system 100, so we'll go ahead and hit enter. So a big difference between Cisco and Juniper is that to set up on Cisco, the command would be router BGP and then autonomous system 100, or router BGP 100. However, in Juniper, it's actually set under the set routing options, and then we put in the autonomous system 100. So that's our first major difference. And the next thing we're going to do is set up a BGP group. The way we're going to set up BGP and our connection between R1 to R2 is by doing the command set protocols, and this is where we're going to have all of our routing protocols listed. You can see BGP is under there as well, so we're going to do the command set protocols BGP. And if we do a space question mark, what we're going to do is we're going to define a group. So we're going to call this set BGP group, and then we can name it whatever we want. We're going to name it EBGP for external BGP to R2. If I do a space question mark, now you can see that we have a lot of options under BGP that we can use. And one of these options that we're going to use is the type option. So this is going to be our first statement under our BGP. We're going to do set protocols BGP group, then our group name, and we're going to use the type and then space question mark. You can see we have two types. We have internal for IBGP group and external for EBGP group. So obviously this is we're going over external BGP in this lab, so we'll do external and hit enter. I could also set all of these options under the BGP group by doing the edit protocols BGP group and then EBGP to R2. So now it's taken us to edit protocols BGP group EBGP to R2. Under this, if I just do the set, now you can see that we have everything that we had before. So this, you can do it either way. If I do a show from here, you can see that we have already set the type to external. So again, we've specified external BGP for this BGP group. The next statement we're going to put in here is we're going to set our peer autonomous system. So we'll do that by doing the command set space question mark. We have the option of peer AS. So this is the autonomous system number of our neighbor. In this case, from our lab, we're going to be peering with Autonomous System 200, which is router 2. So we'll do set peer AS and then 200. And our last statement to get external BGP up and running from router 1's point of view is going to be the statement set. We're going to use the option of neighbor. So set neighbor, and then the address of our neighbor. So our neighbor is going to be 12.12.12.2, and we should be good. So if I do a show command, under our BGP group external BGP to R2, we have three options. We have the type of external, we have the peer autonomous system of 200, and we have our neighbor statement of 12.12.12.2. The last thing that we're going to do on R1 to finish the configuration on R1 is we're going to have to create a simple routing policy which is going to export our loopback into BGP. Excuse me. So we'll go to the top of the configuration and we'll do the command set policy options, policy statement, and then we're going to call this policy. We're going to call this policy export to BGP. Our term is going to be term 1 or T1, and what we are going to export or advertise into BGP is going to be interface loopback 0.1. So again, our from is our match statement, so then we need an action. So when this is matched, we're then going to accept. And that is not the end of our configuration. Now that we have our routing policy set up, what I have to do is go under Edit Protocols, BGP, and then the group is EBGP to R2. And under our BGP group, we're going to now apply our routing policy, which was export to BGP. We do that with the command set. Then we have the export option, so export policy. So set export. And then what we can do is just go up and copy this, paste it in. So set export, export to BGP. Now if I do a show, you can see that our export policy we have now added to our BGP group. Let's go ahead and commit this. So again, the whole reason for the routing policy is going to be to add the loopback 0 or the subnets on loopback 0.1 into our BGP process. Some of the statements that you can do within BGP are show BGP summary. We can see that our neighbor is active, and we all know that active is not a good state to have in BGP. We want to see it become established. With this statement show BGP summary, we have our peer of router 2 that is in Autonomous System 200. Also, if we do show BGP, we can do the group option, group detail. This gives us a very detailed look at our BGP group. Our BGP groups configured on a local router. So the name of our BGP group is EBGP to R2. We have an export policy applied to this BGP group, which is export to BGP. We have a total number of peers of 1. and it shows us the number of BGP prefixes we're receiving, accepting, and a whole lot of other information. So again, this is a very good command to take a look at. Okay, so R1 is done for now. The next thing we're going to do is go to R2 and get it configured. So let's go ahead and get out of R1. We'll set CLI logical systems to R2 so that we're looking at router 2. And again, the first thing on R2, like we showed you on R1, we're going to do the set routing options and then autonomous system, and then R2 is going to be in autonomous system 200. So let's do set routing options autonomous system 200. The next thing we're going to do, router 2 is connected to R1 and R3, so we're going to have two connections that we're going to have to set up from router 2's point of view. First, we'll set up the external BGP connection from R2 to R1. We're going to do this by doing the command edit BGP group. Edit protocols of BGP. Then we're going to create the group name of EBGP to R1. We're going to set the type to external. Again, this is external BGP. We're going to set our peer autonomous system to 100. Again, that's the autonomous system of router 1. We're going to set the neighbor statement to 12.12.12.1. So now that we have the basic BGP group set up to R1, let's go ahead and set up the basic BGP group to the basic BGP group to R3. So in this case, if we look at our diagram again, if you're not familiar with that connection, we're going to be using BGP is going to be run on autonomous system 300 for router 3. And the network between R2 and R3 is again the 23 network. So under Edit Protocols BGP Group EBGP to R3 from router 2's point of view, we're going to set type to external. Obviously, because we are doing external BGP only in this lab. We are then going to set the peer autonomous system to 300 because router 3 is in autonomous system 300, and also we're going to set the neighbor statement, or set the neighbor to 23.23.23.3, and that is where we are peering to. We're peering to router 3 across the 23.23.23.0/24 subnet. Again, external BGP is where we have to put in the IP address or the next hop, how we reach the autonomous system. So from router 2's point of view, the logical tunnel 23 is how we're going to reach router 3. And the IP address of router 3 is 23.23.23.3 across that directly connected path. Okay, so let's go ahead and commit those changes. And now from router 2's point of view, if I were to go ahead and do a show BGP summary, we can see that we have two neighbor adjacencies, one with R1 and one to R3. And it appears as though we are receiving inbound and outbound. We have inbound and outbound packets for our connection to R1. And we can see that we are actually receiving prefixes now from R1, or we are receiving networks. We can see that our connection to R1 we have 2220, where our connection to router 3 is still active. That's because we haven't set up external BGP on R3 yet. However, we do have it set up on R1. So if we do show BGP neighbor and then hit enter, we can see this is also another really good command. It shows us our peer connection to router 1, which is 12.12.12.1. Again, it gives us our TCP port of 179, the autonomous system number of 100, which is R1. It gives us our local information as IP address, autonomous system. It gives us the state. Again, the BGP state that we want to see obviously is established. It shows us our type of BGP neighbor. This is external. It shows us our peer ID, the local ID, our hold time, which is 90 by default. So again, this command gives us a lot of really good information. We can see that our connection is active to router 3 right now. So if we do a show route on R2, now we have some BGP learned routes being added into the routing table on R2. And again, these two routes, the 1 network and the 11 network, are from our R1 in autonomous system 100. The default, so we know again that these routes are coming in as BGP, and the default route preference is 170. And it's also showing us the autonomous system path, which is very important to know for external BGP connections. So we're not going to get into a whole lot of detail about autonomous system path and how to manipulate it in this lab, but it needs to be known that BGP uses autonomous system path for external BGP connections to figure out the best way to get to a destination. Again, BGP is uses a path vector algorithm to determine the best path to get to a specific prefix. So we have the basics set up on R2. Let's go to router 3 real fast and get it configured. So again, we're going to do set CLI logical system R3. And now that we're on router 3, we're going to go ahead and do like we did on R1 and R2. First thing we're going to do is set our routing options. We're going to create set R3 to run an autonomous system 300. Then our next thing is we're going to go under edit protocols BGP. We're going to create the BGP group from router 3's point of view. We're going to do EBGP to R2. And then from here we're going to set the type to external. Again, this is external BGP. Then we're going to set the peer autonomous system of 200. From router 3's point of view, we are going to be peering with router 2, which is in autonomous system 200. Then we're going to set the neighbor statement to 23.23.23.2. Again, this is how we reach router 2 via external BGP, and that's going to be over our logical tunnel 32, which is the 23 network. Okay, so that should be good. Now let's go ahead and do a show BGP summary on R3, and we can see that the connection is still active. Now we can see that our connection is actually up and running. We have our peer, which is router 2 and autonomous system 200. We see that we have learned 2 routes. If we go ahead and do a show route, we can see in our routing table we have the 1 network and the 11 network learned via BGP. And now you can see that our autonomous system path to get to the 1 network and the 11 network, the autonomous system path is 200 and then 100. And that is correct. So we are going to get to the 1 and 11 networks from router 3's point of view. We're going through R2, which is in autonomous system 200, and then R1, which is in autonomous system 100. The last thing we forgot to do on R3 is we forgot to advertise these. We forgot to create a simple routing policy. So we're going to do set policy options, policy statement, and then this is going to be called export via BGP to R2. And then we're going to do this from interface loopback 0.3. So we're going to match that interface, and then we're going to then accept. I'm sorry, I forgot to create our term. Let's go ahead and the best way to do this is to create a term. That way you can go back in and add and delete terms to your routing policy. Let's go ahead and do that just to show you best way to do this. So set policy options, policy statement, and then our name is going to be export via, I should say export to BGP. Term is going to be T1 from interface loopback 0.3. Then we're going to accept. So now that we have our routing policy created to advertise the 3 and the 33 networks into BGP, let's go ahead and actually apply it to the BGP group. Again, we'll do this by going under Edit, Protocols, BGP, Group, and then our group is going to be EBGP to R2. From here, we're just going to do the command set and then export. And then we're going to put in there our export to, our export to BGP routing policy. So now if I do a show under our BGP group on R3, we see that we have the export to BGP routing policy set up. Let's go ahead and commit this. And we'll go ahead and jump over to R1. And the reason we're doing this again is to advertise these into our BGP configuration so that R3 can advertise these routes to R2, and then router 2 will advertise these routes to R1. So we'll do set CLI logical system R1. And then now from R1's point of view, if I do a show route, we now see that we have the 3 network and the 33 network added in to BGP. we are receiving these routes via BGP. And the autonomous system path from router 1's point of view to get to the 3 network and the 33 network is it's going to go through autonomous system 200 first and then to autonomous system 300. And that is exactly right from our network diagram. We're going through R2, which is an autonomous system 200, and then our final autonomous system is 300, which is from router 3. So let's go ahead and try to ping this and see what happens. And if you're following me, then you might be surprised or not surprised at the outcome of this ping. So we're going to source this ping. We're going to do a ping source (1.1.1.1). So we're sourcing this from loopback 1, and we're going to ping 3.3.3.3. We're going to do a rapid ping, and we'll do a count of 1,000. And there you can see that we indeed have reachability. So R1 from its loopback 1, or I'm sorry, R1 from the 1 network can ping router 3 to the 3 network. So that's it. That's how you set up external BGP from a Juniper standpoint. There's a few different things that we had to do, and one of the things I also want to show you, if we were to ping this, if we were to ping from router 1's point of view, just do a ping 3.3.3.3, just do a rapid count of 100, and what you're going to see is that we're getting timeouts. And I'm going to go ahead and explain this to you, why this is happening. The source of our ping when we do this is going to be the exit interface on R1, which is the 12.12.12.1 IP address. If we go to router 3, set CLI logical system R3, if I go to router 3 and do a show route, you can see that we are not learning the 12 network and we do not have it in our routing table. And that is because on R2 we are not advertising this 12 network into BGP. Same thing from router 3's viewpoint. If on router 3, if I'm going to try to ping the 1 network and just leave it at that, what this is doing is it's using its exit interface from router 3's point of view. The router 3's point of view, the exit interface is 23.23.23.3 is the IP address. Again, that's on logical tunnel 32. However, if I were to ping this and source this from one of our loopbacks that we advertised into BGP, say 33.33.33.33, you can see that we are successful. Again, we'll just do a rapid count of 1,000. So it's very important that you understand the basics of reachability in this in BGP and in this lab. If you're just going to do a ping from router 3 to the 1 network on R1, what you're doing is you're going to source this ping. If you just do a default ping, the exit interface is going to be used as the source, which is 23.23.23.3. If we were to go to router 1 and do a show route, router 1's routing table does not have a path to the 23 network. And that is because we are not advertising the 23 network into BGP from router 2's point of view. Or in general, we're not advertising the 23 network are the 12 network into BGP, which is rightfully so. So just be aware of, if you're doing this lab, if you wanted to get those pings to work, all you would need to do is create a routing policy. You could do this, just go onto router 2, create a simple routing policy, and advertise your logical tunnel interfaces into that routing policy, and export that routing policy to your peer groups. I'm sorry, not your peer groups, to your BGP groups, to R1 and R3. But for the simplicity of this lab, we're going to try to keep it, we're not going to try to do too much. I just wanted to show you that if some of your pings, if you're coming back, hey, I can't ping, you got to remember that you got to make sure that you're advertising, the networks that you're advertising to BGP, you have reachability to. And obviously we're not advertising the 12 or the 23 network into BGP, we're just advertising our loopbacks on R1 and R3. So remember to source these pings. If you're pinging from R1 to R3, if you ping to 3 networks, source it from either the 1 or the 11 network, because you have to be aware of the other end of this network. What networks do they have reachability to? Anyway, that's enough about that. Sorry if you already knew all that. Some people might not have known that concept, so that's why I just wanted to show you a successful ping and what it would look like, and then an unsuccessful ping and why it was unsuccessful. One of the last things I just want to cover real fast, and that is a very good command to have from router 1's point of view, you can do what's known as received and advertised protocols. So from R1's point of view, if I do the command show route received protocol BGP, and then we're going to put in our neighbor statement, which is router 2, so we can actually see what router 2 is sending us. So we'll do the command show route received protocol BGP 12.12.12.2. You can see that we have the 3 network that router 2 is sending us, and the 33 network. And both of these routes are being added into the routing table. We can also do the command show route advertise protocol BGP, and then we can show what we are advertising to router 2, and that is the 1 network and the 11 network. And the next hop of self, obviously, because we are exporting these routes from our loopback interface on R1 into BGP and sending them to router 2. If we were to do these commands on R3, if I do a show route received protocol BGP, and then from our neighbor router 2, 23.23.23.2, we are receiving the 1 networks. Obviously router 2 is in the transit path, so router 2 is sending the 1 networks to router 3, and router 2 is also sending the 3 networks to router 1. So when we do show route received protocol BGP from router 3's viewpoint, it's going to show router 2 sending us the 1 networks, and that is exactly what we see. Also, if we do a show route and then advertise protocol BGP, and then our neighbor 23.23.23.2, which is router 2, we can show what routes we are advertising to router 2. So again, these commands are going to come in very handy when you are troubleshooting BGP reachability issues. So that's just the basics: show route receive protocol, show route advertise protocol. Obviously, if you have firewall filters, or if you are having some routing policies that are blocking some networks from entering into the routing table, you can also follow these commands up with hidden. So that's going to show you if you have some, for instance, if router 2, from router 3's point of view, if router 2 is filtering a route, then you can do receive protocols to see if you're actually receiving the route from R2, and if you are, you can do the hidden statement, and then this is going to show you if you are locally filtering this network from being added into your routing table via a firewall filter or a routing policy or other ways. Anyway, don't want to get too advanced for this lab. I just want to show you external BGP, and I believe we did a good job of covering external BGP, how to set it up between 3 different routers, R1, R2, and R3, and 3 different autonomous systems. We showed you the basics of external BGP. We showed you how to export our loopbacks, our interfaces into external BGP from R1 and R3's point of view. So this is the BGP Lab 1 for Juniper. Thanks for watching, and I hope to see you in the next one.